Well, hello everyone. Welcome back to Adrian's Digital Basement 2. I'm back from VCF Southwest in Dallas, and I'm, just looking at the stuff I brought home, and I was given this Famicom or Famiclone cartridge by a friend of the channel, David Rutledge. And I kind of love these clone cartridges from import markets. This one's a Super 920 in 1. Yeah, look at that artwork. God, that's pretty funny. TV game cartridge. This one has this little thing here that holds it together, and well, this cartridge has seen better days. If we take a look at the back, you can see that, well, it looks like it's gotten slammed in a door, or who knows what happened. David told me that this thing didn't work. It says a home game computer on the back, oddly enough. And if we open this thing up, you can see some of the damage there. This cartridge got really squished up against the ICs. If we look at these chips, well, the PCB itself looks a little damaged. Now, David told me that this thing did not work when he tried it. Almost certainly, we have two ROM chips. We have a PAL for decoding something or other. These blobs, well, I don't know what they do. KL3A written on there, KL3A. And this chip here, the AX5202P, I looked this up, and this appears to be a mapper chip. This is a clone MMC3 chip. Now, I got home and thought, well, maybe I could make this work. I could just have to kind of like look for any broken traces on the PCB and, see what's going on here. But obviously, that's not going to be the case because this chip, it has a crack in it. So there's no way that that's going to work. That's pretty much impossible. Once the hermetic seal is broken, that is that. Now, what we can do, though, is we can remove these ROM chips, which, well, I'm assuming one is going to be like 512K because there are a bunch of ROMs on here. The other one will be some amount of size as well. So I need to try to dump these, and maybe we can load these into an EverDrive and kind of get this thing working. I don't know. I've never tried doing that, but it's worth a try, isn't it? Looks like 1993 are the date codes on these two chips, although the PAL here says 9036. This is obviously for installation into a Famicom itself, not a regular front loader NES. Just looking on the back, see if there's anything we can see. We got some flux residue here and there, but everything looks okay. I think the ROMs are going to be fine and undamaged. And I'm assuming these are just going to be standard EEPROM style ROMs. Yeah, see, look at this. See how this is cracked here? The actual fiberglass PCB. That's what I thought I could fix. And it wasn't until I opened this up before I started recording that I noticed, yeah, the big crack that's on there. Anyhow, okay, first things first, let's get these off, and I'll try to dump these. Okay, let's see if I can get these out. Yep, came out pretty easily, that one. And now at this one, did mark these just to indicate, which way they went into these boards. There we go. Underneath, 4M, V4M. So my assumption is the one on the right side is going to be the, what's it called, character ROM, and this is the program ROM. I don't know, V, that's the only thing I think means that. We'll start with the one that I think is the program ROM. All the pins look fine. Put that into the programmer here. Now, if we compare these chips to something like a 27512 on the bench here, there are 2 extra sets of pins, so 4 extra pins on there versus this one. So this is probably a pretty large EEPROM. So I'm going to do a little bit of poking around to figure out what possible EEPROM size this correlates to, and then we'll be able to dump it. Let's start with this one here, 27C040. So this is 512 kilobytes. Turn off the check IDs. Clearly that's not going to work. If we look here, that matches the number of pins that are actually on the chip that's in the device. There are 4 extra rows of pins here. So let's just try it. We'll just do a read, see what happens. Yeah, gives us no pin error, so that's a good start right there. And the way we can see if this is set wrong is that we will start to see looping going on. So we'll look at these bytes here, and we're going to look for them somewhere else in this ROM. Does this have a search function? I don't know. It's probably easier just to save. So I'm going to save this as prgrom maybe.bin. Let's see what that does. And we load this into the EEPROM or the hex editor, and we're going to look for this string somewhere else in here. Now, if there's a 256K chip and I've read it as 512K, it'll loop. We'll have 2 copies of it, so we'll be able to see this twice in here. Search all. Can't find it. Wait, well, obviously it's in here once. Oh, text string, that's the problem. Hex values. Search all. All right, it's only found once. So that tells us that there's no looping going on in here. Well, I don't think there is anyways. Let's do the same thing at the bottom here. We'll look for that string, or sorry, hex values, I guess. We'll find them all. Oops, that's not the right way to do it. You hit search all. Right, it's only in there once as well. Now you might think that you might see ASCII strings in here, but that's not necessarily the case. And that's because when you're displaying text on an NES, you're going to be using tile map to do it. And it's not like those are ASCII values, those are just arbitrary. So unless someone put like a copyright string in one of the ROMs, which we have to imagine was probably removed by whatever company, made this thing. And the company, I'm using that loosely. I don't think we're going to see any ASCII values in here necessarily. It's just not normal. Oh, although, check it out. Look at this. We have some like leftover residuals here from, I guess, the assembly process or the original program code, whatever game this is that we're looking at here. So Relife, Sunset, who knows? But this kind of tells us we at least read this properly. And maybe people, oh, I thought I just saw some more there. What am I doing here? I should just run the strings command, shouldn't I? Okay, so I just ran the strings command. We'll just take a look at this. Oh, look at this, continue, push, start, button. All right, so there's some stuff in here. A lot of kind of random junk though. Anything else that I see? I'm probably missing stuff that people can see as I scroll by very quickly. The plutonium, okay. Congratulations. Oh, here's a copyright string, 1982, 1985, Namco Limited. Someone could probably tell us what game that's from, or at least with the surrounding bits of stuff that's there. Okay, well anyways, this pretty much tells us, oh look, game editor, 2-player game A, 2-player game B. Pretty much tells us that, congratulations, perfect, bonus round, round error, version 1, 1984, by Kiku. Anyhow, this tells us that I think this is definitely the program ROM. I don't think this is going to be a larger chip. I'm not sure. Maybe there are 1 megabyte chips that are in this form factor. I should probably do a quick search to see if that's the case. Ah, yes, a quick Google tells me that, let's go back to the programmer here, that 27C080 is actually 1 megabyte and is also possible in this 32-pin package that we have here. So let's give that a try and see if we see looping, because this might well be a larger chip. Oh, chip error. Yep, got to turn that off every time you change the type on this software. Again, we're going to look for the looping pattern to tell us like what the actual size is on this. Now you could try to analyze this little board here, but it's just easier to do it this way. So we still have the same byte there. So what I'm going to do is I'll save this, and I'll save it as maybe 1 megabyte. Save as. And if we go to our 512K dump that I made, and we're going to look for this hex string, we're going to go to the 1 megabyte one, and we're going to look for this all, search all. Right, it is in there twice. So this is telling us here, if we double click this, that takes us to 7FFFFFF, all Fs, and then it loops because there's that same 78, D8, A2, 3D at the beginning. So that tells us for sure the chip, the program ROM chip that we dumped is 512K. It's not 1 megabyte. So cool. Okay, so I think we have a good dump of this chip. Let's switch over to the other one, which I assume is going to be the character ROM, which is containing the tile maps. My assumption is this might be smaller, but it might not be. I don't know. Let's just read it as the 1 meg chip because it looks physically the same as the other one, and then we'll figure out how much it loops. I'm going to save this as CHR-ROM 1 megabyte .bin. We're going to have to definitely chop this down inside the hex editor here. So we'll drop this onto here, and we're going to look to see how many times we see this byte sequence in here, and that'll tell us all of the loops that we have going on. Search all. Can't find this because I didn't hit copy. I just selected it without hitting copy. Search, find, paste, search all, and oh yeah, it's looping a lot of times. Okay, so this is a lot more than just a loop. I think what I need to do is go to the end, and we're going to have to search for a larger amount of bytes, like all of this, and look how many times this loops. So find all, search all. Okay, 2 times. So this is also a 512K chip, just like the other one. So what we can do is I can just ditch the rest of this. So we're going to go to the end, get rid of that. And now we have a 512K chip. And I'm pretty much sure that this is all character data. Yeah, I'm going to say that is going to be the case. So we're going to save this back to the disk. Range check error. Okay, I don't know what that means. So I'm going to save this as a new file. We're going to save it like this. No error that time. We can delete those files, so we don't need those. And we can delete this file because we know it's not 1 megabyte. We're just going to save it like that. There we go. We have our program ROM and we have our character ROM. Now, the reason why I know that this particular chip that's on here is an MMC3 clone is I searched for it and I found a person talking about it on this NesDev forums, and there it is, the AX5202P chip. It's a Pirate MMC3, and this person was talking about making a kind of a custom cart with a bunch of SRAMs, like a work RAM, 8 kilobytes, that this does not have because there's no SRAM on here, and also character RAM, 8 kilobytes, it's also not on here. That would be another SRAM chip. And I guess I'm thinking that maybe I need to figure out how to find, or maybe I can find an existing NES game that has two 512K chips, both for character and the program ROM. And I'm thinking maybe I can squish the two ROM files together and add an INES header to the start, and then we can edit the header and tell it MMC3 and define the lengths of the two ROMs, and maybe that'll make something that works. I don't know. Looking at this forum post again, though, there's that AX5202P. Those are the two ROMs, program ROM, character ROM, and then we have the two SRAMs. So this is a work RAM, and then we have the character RAM. In fact, looking at this, it's kind of cool. This person actually made this from scratch, and that's pretty sweet. It looks like they really, I think they made this PCB themselves. What year is this post? Oh yeah, 2011. This was before like JLC, PCB, and PCBWay and whatnot, so not a sponsor, by the way. Also, I was doing a little Googling and I found one seller on Mercari that was actually selling this exact cartridge. There it is. Looking a lot brighter and less orange than this one. Is this exactly the same? Yes, the sticker is exactly the same as this. Oops, sorry, I'm just wobbling the mouse all over the place. There was also a couple other ones. Now, unfortunately, they show these cartridges working, and the 64-in-1, which one of the other one works, and the Super 4-in-1 works, but they do not show, they don't show this one working. So I don't know how the menu looks on this one, unless it didn't work in the listing here. Let's do a Google Translate on this. Okay, thank you very much for viewing. A set of 3 multi-carts for the Famicom. Non-smoker, no pets. That means the cartridges won't stink and have hair on them, I guess. Doesn't really talk about anything about the actual game cartridges, especially this one. They don't explain why there's 2 pictures of the 64-in-1 in the listing. It's a different photo. But you can see like the position of this is different. So part of me wonders if, I'm just looking at what's listed here. Chess is 20, Islander, which Island Adventure I assume is his first game. It's the same. So yeah, I'm wondering if this just shows up as 64-in-1, like it's really the same on both. I don't know. Okay, let me try to figure out how the INES header works and if I can squish these two ROM files together and create this INES header that will allow an emulator and then the EverDrive to actually play this particular cartridge. And with an EverDrive, I think it reads the INES header and that's how it kind of switches into its emulated mapper mode. And if this is just MMC3 that's on here, that's good because that's something that the EverDrive that I have can emulate, which means we should be able to play this on real hardware potentially. Oddly enough, I'm looking at NesDes though for MMC3. It says that it does support 512K for PRG or program ROM, but the character ROM is only 256K. And I saved it as a 512 and I don't think it mirrored. So let's take a look at the file again. So I'm going to look at this beginning of the file here and I'm going to try to see if this is hex value. Look at this, all, search all. Huh. Yeah, the problem is that is found multiple times in this file, but that just could be a standard header that is found sort of in multiple games, like for the character ROM that is. So I don't think this is necessarily a good thing. And that's why I jumped to the end And I was looking for kind of this sequence here to see if this repeated or is found multiple times. And it's not, it's just found once. Well, it was found twice originally when I dumped it as a 1 megabyte. Let's look for just this one line instead. Same thing, only found once. How about this right here? Search all. Yeah, go again, only once. So we saw that it goes up to basically 8 and all zeros, well, 7 and all Fs. So that means that if we go to the middle of the cartridge, that's right here. This is the middle of the cartridge. So this is where it would be looping if it's 256K. But if we look at the beginning of that second 256K bank, all Fs and then 384C, and that is not what's at the top of the file. So it kind of makes me think that the PAL, the chip that's on here, maybe allows some kind of bank switching for the character ROMs, which would imply that perhaps when you're in the menu to select your game, somehow there's an output, or somehow it gets triggered and that swaps the character ROM probably from like one half to the other, or something. It might even be more complex than that. It's hard to say. And looking at this, looks like the PAL chip, which is right there, there are traces that go down to the character ROM. So I think what I'm going to have to do is probably split this file up into 2 chunks. And then I'll try to load each one and see what that does when we can kind of smash this together into a ROM file that uses just a standard MMC3 mapper. So I went ahead and saved it as part 1 and part 2. So I split that up. Oops, I keep getting these range errors. I don't know, there's a bit of a bug in this program. All right, so this is the beginning of part 1. That's the beginning of part 2. So I went ahead and I grabbed a ROM that was already an existing game that has 512K program ROM, 256K character ROM, plus the INES header. Copied it in here, renamed it Big Game. And from what I read, the INES header is always exactly 16 bytes long, so that'll be that entire first row. So what I'm going to do is I'm going to make a new file. So we're going to start with program plus, and we'll do character plus 1, and we're going to try game 1.nes. And what that's going to do is concatenate those files together. That's on Windows. Of course, on Unix or Mac, you would use the cat command. And we're going to do this again, but we're going to do part 2, and I'm going to call it game 2. So that's going to make 2 768K files, but this is missing the header. So if we open up the hex editor again and we go back to Big Game and I copy this, and I think there's a way to insert, paste insert. So that adds the INES header to the start of game 1. So we'll close that. We'll open up game 2, and we're going to do the same thing. We'll paste insert, and we'll save that. Now game 1 and game 2 are both 769K. We can delete these back files. I don't need those. We will probably need to edit the INES header, though, because, well, I don't know. Let's just try using it, I suppose, actually. But I think like Kirby's has a battery backed up RAM, which this clearly does not have. I've loaded up Messin, an NES emulator, and let's just try game 1. The game has crashed. Okay, that did not work. Let's try game 2. Nope, didn't work either. Does this have an editor for the INES, the header? Yeah, here's the header editor, and it does already have 512, 256K, no work RAM. Let's take off battery. NES, Famicom, Dendy, that's fine. NTSC, mirroring type, I guess, whatever, horizontal. Is this the correct, is that the correct mapper? We have 2 different types of headers. And a quick search here. Looks like INES mappers, mapper 4 is correct for MMC3, but also 118 and 119. I mean, I could try 118. Game has crashed, invalid opcode. Okay, I assume I'm doing something wrong here. And I wonder what this PAL is doing on this board. It really looks like it is only interacting with the character ROM. And I would think the program ROM would run even with the character ROM being invalid. That shouldn't make a difference. You just have really corrupted graphics. All right, so let's see about this Messin debugger. I am very unfamiliar with how to use this stuff. So if we reset this, yep, there it is. It jumped to, I'll make sure you can see what I'm pointing to, FD2B. So what we're going to do is we are going to step into, so F11 should go 1 instruction at a time. So it's executing code right now. And here it is jumping to 4E93. So it doesn't crash instantly. It's actually doing stuff. It looks like setting up the PPU, and we don't see, where's the graphical window? Just move that right there. And we'll hit an F11. So we're still going. It's jumping back. So that means there must be a little bit of memory initialized at the beginning because there's like a bit of a stack. Okay, so it's doing something with the PPU. Okay, so I did run one frame. Now we have the green screen here. It's still doing this. Let's go back and do another frame. Run one frame, F8. Ah, okay, it's jumped all the way up here. So it still hasn't crashed though. It's sort of stuck in a loop here. It's doing something, obviously. We can run scan lines with F7. This runs an entire scan line at a time. And then F8 does an entire frame. Okay, there's another frame. Ah, okay. So this is where we have this stop instruction, which I think is invalid. Oh yeah, there's a break right there as well. So something ended up jumping to this location in memory, which ended up basically crashing the console, which is exactly where we are stuck right now. A part of me wonders if there is a problem with the character ROM not being mapped correctly because the PAL is doing something on here. Okay, I'm just sort of poking around here, looking at the boot sequence, and what it's doing, I don't know, just a bunch of stuff, but it gets to this jump subroutine, F3, D3, that's this right here, so it goes there. No, I can, wait, what's the key again? Step, F11, step into. So we do step 11, it goes there. So this is now jumping to, well, what's in RAM. So this is in like the 0 page, and this happens to point to B3, D6, so we hit that. And I have a breakpoint there. That's how I found this. And now it's going to do this stuff. And it just sort of runs in this sequence here for a while. And then it hits the stop instruction. And that's basically where it crashes. And there it goes. It crashed right there. Invalid opcode. Now this kind of makes me think that this part of ROM here probably should be switched out. I'm assuming the MMC3 mapper, and I guess all of the stuff we're looking at on screen here probably has some stuff to do with the mapper registers, but it can bank switch out ROM. It can switch to other parts of the ROM. And my assumption is this should be switching to probably something else. So it shouldn't be crashing here, but it is. There's probably something I'm missing or don't understand how to do. What are these down here? Entry points? I wonder if these are the registers for MMC3 mapper. I should probably look at NesDev. So it looks like the MMC3 has 4 pairs of registers available in these locations. Even addresses, select the low register, and odd addresses, select the high register. These can be taken or broken into 2 independent functional units, memory mapping and scanline counting. So you write to the registers, which are normally ROM, right? So you're actually writing to ROM addresses, which normally don't do anything, right? But that's how it's able to pick up these register writes. I guess you can't read it because obviously when you read back the actual ROM space, you're just going to get what the ROM code is. But we can see that the various values of ROM are existing here in the space that we're looking at in the debugger. Now, going back to our debugger, if we hit continue, we can see exactly where this crashing is happening, B3, D6, which is obviously in this space right here. I don't really get what's happening here with this code, and that's because this is loading from RAM, the 0 page, into the accumulator, and then it branches if positive, says it right there. It jumps to the specified location, which happens to be B3, DC. Well, that's right here, and it just runs and then executes a stop, and that just halts the system. I don't even know what STP is. I stop is, I assume, an invalid opcode of some kind. I wonder if I should just edit the actual ROM file itself. It looks like it's telling us right there that it exists address 133E0 in the file. It's bytecode 12. I must be reading that wrong. 133E0. 133E0. According to what's in the file, it's actually an OE. Change this to ROM address. I think this is actually showing us like the actual stuff that's in the file. Oh, I just realized what's happening. There's the INES header. So I got to remove 16 bytes. Okay, let's go back to that. I was sort of looking around here and I lost my place. So we're just gonna run this again, reset, and we'll hit F5 to execute. Okay, so I'm looking for 133E0, but I need to be offset by 16 bytes. Oh, it's right here. Yep, it's the next line. Okay, let's change this to no operation, which is an EA. I'll save this. So that will just do a NOP, and then it's going to go to the break. You know, when you think a break would crash, like on a normal 6502, that would break, or crash, I mean, but it causes the CPU to jump to its IRQ vector as if an interrupt had occurred. So maybe that's normal for NES to use that kind of thing. So let's reload the ROM, and let's execute now. Okay, so there's our NOP, and our breakpoint's still there. So save slot is empty. Oops, okay, that was the wrong thing to do. I gotta hit continue. I gotta turn off this breakpoint, turn off the breakpoint, and let's reset the system and hit F5 to execute. So it seems like it's frozen just at this green screen. And if I break into the debugger and we just hit like F7, I mean, it's just sort of stuck in an infinite loop here. Okay, so it didn't crash at least. It's just stuck. Yeah, not doing anything. So this is obviously far above my pay grade. I am far from a software developer, especially on the NES, so I don't really know what I'm doing. And clearly assembling the ROM this way does not work. Green screen, which is pretty much the normal like initialization state on the NES, or at least on Messen. Like if we load a different game, the first few frames will be green like this until it, initializes the PPU, and then it's just stuck. And yep, it's sort of doing this stuff here. Okay, well, it kind of tells us that even though this is supposedly an MMC3, there's obviously more going on this board, and maybe this PAL has something to do with it. I guess the question is, for folks watching this, do I need to try to dump this PAL? It's just an L PAL, so it's not the R registered version. The L version, I think, should be dumpable, but is that really going to work without fully reverse engineering this whole PCB? Looks like it's connected to, at least on the bottom side here, mostly to what's going on with the character ROM and this resistor here. But I don't see, well, at least on this side, it's not going to any of the pins on the main mapper IC, but it could well be on this side. Yeah, I mean, there's stuff going over here that's under the chip. It's going to the pads where this resistor is, not that one, but these ones. Although those just go down over here. So that probably is character ROM related. So I don't know. I think what I'm going to do is I will upload these files to archive.org, the 2 ROM dumps that I have. So if anyone wants to kind of poke around and take a look at it and give it a try to see if you can figure out how to make this thing work, then let me know. It's almost certain that there's nothing on here that's super rare or weird or whatnot, but you never know with these multicarts, right? You never know that there might be some kind of fascinating, weird ROM hack version of something that's maybe lost to time. I don't know if this one's been dumped. It's quite possible this exact cartridge has been sold under many, many other names previously. And I did find that one listing on that website for this cartridge, but it could well be that this was used all over the place. And in that case, I know some of this stuff has been dumped and is available on some of the forums and stuff. But it'd still be interesting for anyone who's good at this stuff to take a look and let us know for sure. And I will hold on to this PCB here just in case I need to do any further reverse engineering or try to get the contents off that PAL. But I think generally it's not going to be necessary for running this on an emulator and then, of course, running it on EverDrive, so on real hardware. All right, well, that's going to be it for now. Thanks very much, David, for thinking of me with this cartridge. Pretty awesome stuff. It would have been neat if we could make it work, but obviously with this break in this chip, that's not going to be the case. I suppose, actually, if someone's able to find a source of some of these chips, I didn't even look on AliExpress, but I could try to replace it, and then I could put these ROM chips back in this board, fix these broken traces that it clearly's got in the middle here because there's a big kind of hole in the PCB there. Then maybe this could be made to work again in real hardware, this actual cartridge anyways. That'd be kind of cool. So yeah, I suppose also if anyone has a sources for these chips that's not ridiculously expensive, let me know. I found one listing for one that was like surface mount, a clone of that chip that was like a small surface mount chip. I suppose it's used in more modern multi-cart things, but the 40-pin tip one would be what this one obviously needs. So if anyone has a source for those, I suppose let me know, and hopefully we can just go with the emulation route and just get this thing working on a multi-cart. That would be or on an EverDrive or emulator. That would be the easiest way to go. That's gonna be for this video. Thanks to everyone I got to meet at VCF in Dallas. My voice is still a little bit raspy. I talked so much. I was so tired when I got home, so it took a little bit of time for me to recover. My voice is sounding better, but it's still sounding a little raspy actually. And I've been home for 2 days now. But anyways, hopefully that'll get back to normal soon. And I guess for now, that is going to be that. So thanks to all my subscribers, all my supporters on Patreon, YouTube members. Comment down below if you have any thoughts of this. Thumbs up if you liked it, thumbs down if you didn't, all the usual YouTube stuff. And I guess that is going to be that. So stay healthy, stay safe, and I'll see you next time. Bye.